2 to 5 from f of x dx, minus, I'm going to copy this one, the integral from -2 to -1 from f of x dx. Okay, so let's picture what this is. So we can clarify what we need to do here. So I'm going to picture this. I don't have the function and I don't need the function. But I know that 1, 2, 3, 4, 5. The integral from -2 to 5 from this is this area, where this is f of x. From this area, they want us to subtract the integral from -2 to 1 to -1, from -2 to -1 from f of x dx. They want us to subtract that. Can anyone now, after we pictured and created that figure, can anyone tell us what to write and how to condense this? Anyone? So this is this, and this is this. What would be the answer? Condensed as one integral.
-2 to 5.
But we are subtracting this. So this is the integral from -2 to 5, but we are subtracting this area.
So -1
Yes.
to 5?
Yes, indeed. -1 to 5 from f of x dx. Awesome. Good. Thank you. Good. So let's look at one more property here and move on. We'll come back and look at any of those integrals. But I need to present something from 5.3 in order to be able to come back. But I would like us to look at any of these problems, because this is based on the properties that we looked at, from 65 to 68. Okay, I'll choose 67. So we have 2 less than or equal to -1 to 1, the square root of 1 plus x squared dx, less than or equal to 2 the square root of 2. Okay. In this class, we will not be able to determine this. You can say, I can plug it in the calculator. That's true. You can. But that's not the point here. We're not asked to determine this. No, we are asked to show that this integral is a number somewhere between 2 and 2 the square root of 2. We're not asked to calculate this. We're asked to show that whatever this is, it's a number between these two. That's all we're asked to do. So our starting point has to be with x. Can anyone tell us where is x in this problem? If we look at the integral, we should be able to identify that x goes from what to what?
-1 to 1?
Absolutely. It was a silly question, I know. Good. We've done this with the squeeze theorem, similar to the squeeze theorem, step by step building the function. So right now I only have x, but I want x squared. So now if x is a number between -1 and 1, so here's the interval, -1 and 1, where will x squared be? Why x squared? Because this is what I have here. I need to build this function in the middle. So better to graph the function, right? So x squared, the graph of x squared is this. And this is between -1 and 1. Okay. So what is the function value then? The function value will be between this and this. Whenever x is between -1 and 1, x squared will be between this and this. Between this and this. What do you think? So if x is between -1 and 1, y is between this and this for x squared specifically. What and what?
0 and 1.
Thank you so much. Do we all agree with that? Let me know if you have questions. Okay, so I built this piece. What should I do to all three sides to get closer to this? What should I do to all three sides to get 1 plus x squared in the middle? I know it's a silly question.
Add 1.
Very good. 1 less than or equal to 1 plus x squared less than or equal to 2. Awesome. I'm closer. Now I have this piece. What should I do to all three sides? Because this is a positive number, this is a positive number, and this is a positive number. Otherwise, I wouldn't be allowed to get this.
Take the square root.
Thank you very much. Awesome. Well, this is silly. I have to write 1. And we had property number 10. Constant, function, constant. Then the integral from this, integral from this, integral from this. Okay, then what I have is from -1 to 1, from -1 to 1, from -1 to 1. The middle, of course, there is no integral without dx. It's the sum of base times height plus base times height. The sum comes with the base and the function. So all three have to be present, even if it's 1. Good. Now we know how to determine this side according to the property. We wrote it a few minutes ago. M times b minus a, m times b minus a. M times b minus a. B minus a with 1 in front. M times b minus a. I'm getting ahead of myself. So 2 to the square root of 2. So we showed that indeed we don't know what this integral equals to, but we show that is between 2 and 2 to the square root of 2. That's how those properties work. We had a couple of examples. Okay, finally, and we can still stay on 5.2, but now I have to start 5.3. Explain what I needed to explain, and then we'll go back to those examples that we just skipped. FTC, fundamental theorem of calculus. It has 2 parts. Part 1 in a minute, I want to start with part 2 because I need it now. Part 2 teaches us how to find a definite integral. Okay, so it says the integral from a to b from f of x dx, we already know, is the antiderivative evaluated a vertical bar from a to b, which means f of b minus f of a. So FTC shows us how to determine a definite integral. The integral from a to b from f of x dx, we have to find the antiderivative. And I know you're going to ask, wait a minute, you just showed us f of x plus c. Yes, but when we plug in b, and then when you subtract when we plug in a, the c goes away. Secondly, this is not an indefinite integral to even worry about c. This is a definite integral. There is no need for c, and this is the reason why. So the antiderivative evaluated from a to b, but always in this form. b first minus a. Crucial to remember that f of x must be continuous on a comma b. And you can say, what if it's not? If it's not, you have to wait till calc 2. If this is not continuous on a comma b, closed interval, you will have to wait till calc 2. That will be called an improper integral. You don't need any of this till you get to calc 2. Okay? So f of x, in order for FTC to be applicable, f of x has to be continuous on the interval a comma b. Knowing this, now we can go back to any of the problems from 5.2 that we skipped. So for example, this. Let's look at 50. You can choose the next. So now on 50, I have the integral from 2 to 10 from x to the 6th dx. All I need to do is find the antiderivative and evaluate it from 2 to 10 and get the number. Can anyone give us the antiderivative? Which function I differentiate to get x to the 6th?
X to the 7th over 6.
Very good, but it has to be the same number. Right? Because when I bring 7 down, they have to simplify, and then that's how I get x to the 6th. So whatever that power is, I have to have it in the denominator. Perfect. Remember, keep the constant outside, 1 over 7. Plug in 10, and subtract when you plug in 2. Okay? Whatever this number is. Let's choose another. We cannot do this just yet. These are just in terms of areas. That's what they say, because we cannot determine everything. But here we can. So please choose any of these. Which one? Anyone?
Can we do number 42?
42. Very good. 42. the integral from -1 to 3 from 2x minus 1 dx. Perfect. Okay, so here, I should have said this from the very beginning. We always have to emphasize that. So is this function continuous on 210? The answer is yes, it's polynomial. So that's why we were able to apply FTC, part 2. In other books, it's part 1. It doesn't matter. FTC. Is this function continuous on -1, 3? Yes, it is. So all I have to find is the antiderivative and evaluate it from -1 to 3, plugging in 3 first and subtracting when I plug in -1. Can anyone give us the antiderivative of 2x minus 1?
X squared minus x.
Yes, x squared minus x, because when I differentiate this, I get this. When I differentiate this, I get that. Perfect. So now I plug in 3. I get 9 minus 3 minus parentheses. I plug in -1, so I get 1 plus 1. 9 minus 3 is 6. 6 minus 2 is 4. And now we are ready to continue with the actual 5.3. And we can choose, you can choose anything you want from, not yet, this is part 1. I said 1 minute, so we have to practice this. So you can choose anything here, and you can choose anything here, from 25 to 54. Now we are equipped with what we need to determine all these integrals, because now we know how FTC works. Before you choose, I just want to say this. What if I have the integral from -1 to 2 from 1 over x dx? What will you say?